All right, that sounds like a good place to stop and get started. So, good morning, everyone. Hello, welcome back. We are in the middle of one of the most fascinating types of functions, exponentials, and more specifically, logarithms. Exponentials are great, and very applicable, used for a lot of things. Logarithms, though, it seems are less common, but in my opinion, they're a little bit more interesting. Okay, all you do is you flip one to the other. It's just the inverse of exponentials. And a lot of the same things, the same techniques will apply. We'll see that more uniquely tomorrow when we get into the properties of logarithms and how they tie directly into the properties of exponents, which is very cool, interesting stuff. But for today, we're just dealing what is the basic log, how do you go from exponent to log form, and solving log equations. And we'll just have some more practice thereof. So to start off, let's look at yesterday's worksheet and go over the answers there. So go ahead and take that out and check your work as we go along. And feel free to stop me at any point to ask good questions. Or ask bad questions. You know what? Ask me ridiculous questions. Here we go. We can get the whole page on screen there. So converting into log form. Remember, you're always matching base to base. Okay? Log answers the question of what is the exponent. So log equals whatever the exponent was, and whatever the exponent equals, that's the argument that log is taking. So you switch those numbers around there, and 4, 5, 6 do the same thing backwards. And yes, you can absolutely have a log base 1/7 of 1 over 343 equals 3. It seems absolutely ridiculous, but it totally works. Then down here we have evaluating each expression from log form. Again, you might want to consider, for example, turning this into exponential form. So log base 4 of 64, that says 4 to what power is 64? And maybe that makes it a little more clear of what you have to find there. Oh, okay, so I start counting off 4 times 4 times 4, right? How many times until I get to 64? And the answer there is 3 in that case. Most of these you should be able to get, I would say, right? Powers of 4 are just powers of 2. Got to know your powers of 2. Powers of 3, get to know those as well, so that gets involved here. 27 is itself a power of 3. Okay. Recognize that. Powers of 5, those are good ones to know as well. 625, 125, those pop up in a lot of places. And of course, powers of 10, those ones should have been extra easy. It's just counting decimal places, except for this one, right? This one's a little tricky, right? Is it 2.5? 100 to the 2.5 power, right? 2.5, aka 5 halves, right? As a fraction, this would be negative 5 halves. Because first, you need to take the square root of 100 to get down to 10, and then 10 to the 5th gives you 100,000. Okay? So overall, 100 is raised to the 5 halves power to make 100,000. All right, any remaining questions on the front page there? Then let's go to the back page. Now we had to solve these equations or inequalities. And a lot of this, some can be easily found by just rewriting into exponential form, and that clears up where the variable is, or some, you might want to simplify just this one, okay, log base 2 of 32. Simplify that expression on that side, and whatever that number is equal to 3x, and then solve, right? It's 5, by the way, right? And now you have 5 equals 3x, solve for x. Okay. Others, once we get down to, let's say it's 7 and such, we're going to make use of the fact that it's a log of the same base on both sides. So we can have our special property. Technically, we're exponentiating both sides of 4 to the, but effectively we can just cross out the log and just say, hey, 3x minus 1 equals 2x plus 3. Solve for x. Done. Right. Inequalities, the text loves to throw the inequalities in there alongside the equations. The process is almost entirely the same. Except you would include the different signs there. Okay, any questions from this page? No? All good? Okay, then your assignment for today is the additional practice worksheet. Get these down pat. You want this to become almost as automatic as multiplication. I say almost. It's a bit unreasonable as multiplication. That's become like so fast. But it should at least become as simple for you to process as solving a basic linear equation or running through your multiplication tables. Okay? We want these to become at least the translate from one to the other. That should be habit. I want you to get to the point where you look at these and your brain automatically goes, hey, I could also put that in log form. Here's what it would look like. And automatically make that adjustment, make that conversion, so you can then make the judgment call of, okay, in the context of a more in-depth problem, right, such as solving an equation, what form do I want it in, right? Here, my x is right there. It would be base is 3 to the 5 equals x, right? So if I switch this to exponent form, I will be equaling to x. I'll solve for x just by rearranging it, okay? So I want you to be able to look at that and have that bit go in your head and be like, oh yeah, that's going to solve for x automatically. Just rearrange it there to exponential form. Done. Okay? And then make use of the other properties to solve there. Okay? That's your goal. Mastery and automaticity. Automaticity. Yeah. All right, so take it away. Let me know if you have any questions.